in this part of the video, I will talk about the code for the experiment. So before I do that, I kind of want to give a quick premise of what the experiment is overall. So overall, what we want to achieve is we have a stepper motor, or I have a stepper motor, connected to our Tiva board. So essentially what I want to happen is I want to code a program so that the Tiva board um, rotates exactly 120 degrees um, clockwise, and it rotates back 120 degrees counterclockwise, right? So yeah, that's pretty much the premise for the experiment. So before I get to the actual code of the experiment, I kind of want to quickly talk about the setup for the experiment in order to enable it. So for our setup GPIO, right, we first want to enable the clock to the GPIO module. So that's line 40 here. Um, Essentially, I wanted to enable the clock at the GPIO module. So in this case, we only used, so I'm using the big board, or the Tiva board, right? The Tiva big board. And in because I'm using the big board, the only port that I used was port L. And yeah, so, and then in order to enable or to allow um, time for the clock to stabilize, um, that's what line 42 is for, right? And yeah, and then on lines 48, what I did there was, so we only have output pins, right? Because we only want an output to happen. Like, we're not inputting anything so that the motor could turn. All we're doing is we're just writing a program, telling it what to do, and the only thing that's going to happen is just an output, right? So in order to make that output happen, I essentially just had to enable the output pins, which were pins 0, 1, 2, and 3. So that, as you can see, that's what I did in line 48. And then now if we look at line 52, essentially I had to, in order for it to work overall, I need to enable those pins, right? I need to digitally enable the register on all the GPIO pins. So that's what I did there, and yeah. So now if we go back to the top, right, um, something that will kind of be used for our experiment is we have defined, or Professor Erzlin, which he did this already, but I kind of want to go over it. He essentially defined counterclockwise and our clockwise and our counterclockwise, right, as 0 and 1. And then here, what I had to do was I had to essentially use this pointer stepper and essentially equal it to our port, right? Our GPIO port L, pins 0, 1, 2, and 3, and shift it twice so that we could use it essentially in our code. Now let's talk about the code for experiment 1. So the code for experiment 1, right? Inside here, our int main function, we have our integer. We have a variable here called I, right? It's an integer and it's set equal to 0. And then we have our setup GPIO, right? Which is calling back to our setup GPIO function, which is what we previously had, or what I previously explained. And then here, right, we have our pointer stepper that we created up here in line 16. So yeah, so now we have to set that stepper pointer equal to the step 1 value for experiment 1, right? So how did I get this number? This is supposed to be 8. How did I get this? So I go to the table that we have, and from the table here, we can see that it is for step 1, the value for step 1 for the first experiment, right? So count this as 1. So this is 1, 0, 0, 0. So that's 8 in hexadecimal. So yeah, that's how I got that number of 8 in hexadecimal. And then, okay, so in the next one, right, we have a while loop, and then inside that while loop, which says while 1, we have 4 loops, right? So we have to basically, this I here is going to go from 0 to some number, right? So this number here, I got 137, right? Because essentially this number here, I want it to be the number of steps for 120 degrees divided by 5, because it's divided by 5 because our s, right, from our stepper motor function is 5 here. So we want to divide it by 5. Okay, so how did I get this number, right? How did I get the 137? So we know that our so that in a full step, um, for the motor to turn once one 360-degree turn, it takes 32 steps, right? So it takes 32 steps for one full 360-degree turn, right? We only want a 120-degree turn out of that 360-degree. And another fact that we know, right, is that our stepper motor has a gear ratio of 64 to 1. So we're going to multiply that by our degrees. So we have 64 turns, right? And that gives us a total of about 21.33 turns. Okay, cool. So now that we have our turns, we could find our the number of steps it'll take, right? So we have our number of turns, right? So 33 turns, and then we said that for every one full 360-degree turn, there's 32 steps, right? So for every one turn, there's 32 steps. So once we multiply those numbers out, we get about 682.5 steps. So now that we get that number, right, and in our code here, right, we said we divided by 5 because our s here is 5, right? Our s is 5. So if we divide that number by 5, we get 136.512, and essentially I rounded it up, so I got 137. And again, yeah, that's how I got the number. So pretty much this first for loop is when it's going clockwise, and the second for loop is when it goes counterclockwise. So yeah, that's pretty much it. Okay, so now let's go into the actual code for the experiment, right? So this is kind of like the int part, right? And then this, we're going to go into this stepper motor function up here. So if we go into that, right, let me uncomment this because I have it commented. Let me quickly uncomment this. Okay, so as we can see here, right, so for experiment 1, we first wanted to implement the rotation of 120 degrees using an array. So I created this array here, right, which has the step numbers, the step numbers in hexadecimal, pretty much, right? So we had, like, you know how the value here, the step 1 value, we had as 8. So step 1 value, step 2 value, step 3 value, and step 4 value. So this is 4 steps, right? So now let's talk about the implement pseudocode. So for this pseudocode, right, it says if the direction is going in clockwise motion, then use this IDX variable here, this static IDX variable that we created, and increment it by 1. And if it's going in counterclockwise direction, we decrement that one, right, by 1. And then now we check the IDX range. So if IDX is less than 0, right, we decrease IDX by the size of our step array. Else, if the IDX is greater than or equal to the size of the array, then we set that IDX equal to 0, and then we simply set the stepper, right, the pointer stepper, equal to the number of the IDX. So the steps, right, the steps of the array, we set it equal to the steps with the number of the IDX array. So step it is going to be 0, 1, 2, or 3. Yeah, that's going to be determined from these. And then we update our I, and then we delay 10 milliseconds. Okay, so now that we have our pseudocode implemented, now I'm going to show the results for the experiment. So let's get to it. Pretty much what we wanted the stepper motor to do was we coded it so that it would rotate 120 degrees in a clockwise and a counterclockwise motion, right? So yeah, as we can see here, right? So what I did was on these post-its, I used a ruler and a protractor to essentially kind of prove that this angle is that it is 120 degrees that it's rotating. So as you can see here, right, it hits this line here, whichever line we could count as 0, and then it counts as 120 degrees going in this direction. So right now it's going in a clockwise direction, right? And then once it hits this 120 degree mark, see, it's going to go back in a counterclockwise motion. And yeah, but this is basically one phase at a time, and it's a full step. And it's the simplest, but it's the least used, and it's the one with the least amount of torque. So yeah, but that's pretty much it.